Hi, my name is Rajat. I'm an engineer with National Instruments. Today I'd like to introduce you to the 14 gigahertz high-performance vector signal analyzer from NI, the PXI-5665. For this video, we're going to compare the 5665 to another high-performance boxed instrument, the Agilent PXA. Let's go ahead and take a look at my setup. Here you're seeing the 14 gigahertz 5665 in the center of my chassis. I also have a couple of CW sources and a vector signal generator that are going to be generating signals to both the 5665 and the Agilent PXA. I have a splitter with equal length cables so the same signal reaches the 5665 and the Agilent PXA at the same time. Now, most of you probably already know that NI PXI instruments are inherently faster than traditional boxed instruments. And that's what I'm going to show in my first tab on my LabVIEW front panel here. Here we're doing something called a Harmonics test. We're hopping frequencies 5 times, all the way from 1 gigahertz up to 14 gigahertz. You can see on the screen I'm plotting the narrow bandwidth spectrums of each of the signals at every frequency and making an amplitude measurement. Right out of the box you can see that the 5665 is almost 1.7 times faster than the Agilent PXA, even for a simple test such as harmonics testing. Now, harmonics testing is one thing, and speed is expected to be faster on the 5665. But let's pitch these two instruments against each other for performance specs, such as linearity and dynamic range as well. On the second tab, we're comparing the linearity of the PXI Express 5665 and the Agilent PXA. We're basically generating 2 tones from a couple of 5652s in my PXI chassis and using a combiner to combine those 2 tones. What you're seeing on your screen is the acquired spectrums on both the 5665 and the Agilent PXA. If you look at the little white box on your screen, we're measuring the third-order distortion products of both the 5665 and the PXA. As you can see, the third-order distortion product on the 5665 is about negative 95 dBc, whereas that on the PXA is about negative 89 or negative 90 dBc. Now, these third-order distortion products are usually generated because of the nonlinearities of mixers and amplifiers in the instrument. And we want these third-order products to be as low as possible. We can also go ahead and calculate the third-order intercept, or TOI, of both instruments. And as you can see, the third-order intercept of the PXA is about 19 or 20 dBm, whereas that on the 5665 is about 28 to 29 dBm. Again, the third-order intercept, the higher the intercept, the better the linearity of the instrument. So here we're seeing that the PXI Express 5665 is about 8 to 9 dB better than the Agilent PXA. The third tab on my screen shows adjacent channel power measurement on a WCDMA signal. Now, adjacent channel power measurement is one of the most demanding tests for an RF instrument. It utilizes both the linearity, the noise floor, and the dynamic range of the RF instrument. Now, what you're seeing on your screen is the WCDMA spectrum that is acquired by the PXI Express 5665. We're also seeing the upper and lower adjacent channel power measurements. As you can see, both instruments are really good, and we're getting about 80 to 81 dBc on the upper adjacent channel power measurement on both instruments. Now, we are utilizing noise correction and also utilizing the maximum dynamic range of both instruments. But as you can see, the Agilent PXA is taking about 440 milliseconds to make the measurement, while the PXI Express 5665 is taking about 35 milliseconds. So we are already 14 or 15x faster than the Agilent PXA. One big reason you're seeing this is because of the processing power of the PXI Express 8133 controller in my PXI Express chassis here. Now, I also have an NI flexrio instrument in this same chassis, and that shows off the modularity and the flexibility capabilities of my PXI platform. I can go ahead and switch the processing from the 8133 to my flexrio instrument. I'm using peer-to-peer streaming to stream all of my data at up to 800 megabytes per second to my flexrio instrument and performing averaging and FFT on the flexrio instrument. Let's go ahead and switch that and see the effect. As soon as we switch that, you will notice that the performance of the instrument is still the same because I'm still using the high-performance PXI Express 5665. but my acquisition time, my measurement time has gone down to 3 milliseconds, which makes the 5665 and the flexrio instrument about 140 times faster than the Agilent PXA. In fact, the majority of the time that you're seeing here is only the acquisition time, and the averaging and the FFT is almost negligible. Just for fun and to prove that, I'm going to push my averages up to 100 averages. And I'm going to keep the Agilent PXA at 10 averages. Now you see that I'm taking about 15 milliseconds on the 5665 plus the flexrio. Again, most of this is only the acquisition time. I can even up this to 1,000 averages, and I'm taking about 130 milliseconds, and I'm still about 3.2 times faster than the Agilent PXA, which is performing only 10 averages. Overall, compared to the Agilent PXA, the 5665 is much more modular and flexible, and you can do things that are almost impossible on the Agilent PXA, such as moving your processing from the host PC to the FPGA. Not only that, the NI 5665 is also about 1/10 the size of traditional boxed instruments, is a fraction of the cost, and is about 15 to 20 times faster right out of the box.